Now that we've practiced writing compound inequalities, let's see how we can solve them. Look at this example. It says solve -5 is less than or equal to 2x plus 3, which is less than 7. So I'm just going to rewrite it here. Now we have solved lots of equations in the past, and we've already learned that solving inequalities are very similar to solving equations. In fact, they're exactly the same, except when we multiply or divide by a negative number. Then we have to flip over that inequality symbol. So if you think of this, if you were given something, if you ignore the red box here, it says -5 is less than or equal to 2x plus 3, you would know how to solve the inequality. You'd say, all right, what am I solving for? X, what do I have to get rid of first? Well, you always get rid of whatever's being added or subtracted, so I'm going to get rid of the 3. Since it's plus 3, I'm going to subtract 3, or you can think of it as a positive 3, so I'm going to go minus 3. And whatever we do to one side of the inequality sign, we do to the other. So -5 plus a -3 is -8. Since we're not multiplying or dividing, I can bring down the inequality symbol, and I'm left with 2x. Well, guess what? We're still going to be doing this, except you can think of it as we almost have a third side. Here's what I mean. Whatever, you're still going to be solving for x. You're going to be solving for x just like you normally know how to do. But in this case where we had to subtract 3 from each of these sides, well, you got to subtract it from this part of the inequality as well. So you think of these almost as 3 parts of an equation. Okay, so there's our inequality there, and here's our inequality here. So whatever you do to one side, you do the other. Well, then you got to do to the other side too. You got to do it to the third side. So if you look at this, if we subtracted 3 from the middle here, we're going to subtract 3 from this side and 3 from this side. So we're going to get -8, bring down your inequality, bring down your 2x, your 3's cancel out. 7 minus 3, or 7 plus a -3 is 4. And you can bring down your inequality. Again, what are you solving for? Solving for x. So what do you have to get rid of? 2. Well, it's 2 times x. How do you get rid of it? You divide by 2. Whatever you do to one side, do to all your sides. So -8 divided by 2 is a -4. 2 divided by 2 is 1x. 4 divided by 2 is 2. Now remember, before we bring it down our inequality symbol, you ask yourself one more question. Did you multiply or divide by a negative number? In this case, we divided by a positive 2. Since it's positive, you can bring your inequality straight down. Okay, and we get our solution of -4 is less than or equal to x, which is less than 2. And if you had to graph it, it would make sense that x is going to fall between -4 and 2. So solving compound inequalities, basically the same thing as solving equations or inequalities, we just kind of add another side. Let's look at another example. This one says solve 6x minus 5 is less than 7, or 8x plus 1 is greater than 25. Solve both equations, or I'm sorry, inequalities. You have to solve 6x minus 7 is less than, 6x minus 5 is less than 7, and 8x plus 1 is greater than 25. Same steps to solving inequalities as you've always had. We're solving for x, so we're going to get rid of the 5 first by adding 5 to both sides of the inequality. 6x, these 5's cancel out since it was -5 plus 5, or -5, positive 5. 7 plus 5 is 12. Since we didn't multiply or divide at all, we don't have to worry about flipping our inequality yet. We bring it straight down. Then we keep going. We're solving for x, so to get rid of the 6, we divide both sides by 6. Now notice again, guys, we're not just careful. You have to be careful not to say, oh, the answer is 2. You're right, 12 divided by 6 is 2, but we're talking about all the values less than 2. So make sure you bring down your x and the inequality symbol. Again, before I did that, I should have asked myself, did I multiply or divide by a negative number? No, it was a positive 6, so we can bring our inequality straight down. Then you go to the second inequality. We're solving for x, so we get rid of the 1 first by subtracting it from each side. We get 8x is greater than 24, and then we divide both sides by 8. 8 divided by 8 is 1x, 24 divided by 8 is 3. Did I multiply or divide by a negative number? No, so I can bring our inequality symbol straight down. Now once you get to this part, don't forget to go back and add that or in. Our solution set here is going to be less than 2 or it's going to be greater than 3. Okay? And again, if you picture this on a graph, there is no overlap. 0, 1, 2, 3, 4. Oops. We're talking either the values less than 2 or the values greater than 3. Very close to each other, but still not the same. So don't forget to write the word or in. Okay, but otherwise you're solving inequalities just like you already know how. Let's look at one more example. Negative 3 is less than a negative 1 minus 2x, which is less than or equal to 5. Okay, we know by now it's just like adding a third side. What are we solving for? We're solving for x. So what do we have to get rid of first? Now this one can be a little tricky because it actually is the second term here. Don't forget, sometimes it's helpful to go keep, change, change, and remember that to be a negative 2x. Let me write that a little neater here. So this, it was minus 2x, and I'm going to go keep, change, change, and make it a negative 2x. So what do we have to get rid of first? This negative 1, always whatever's being added on. So since it's minus 1 or it's a negative 1, we're going to add 1 to every side. Negative 3 plus 1 is a negative 2, and we're not multiplying or dividing, so we'll just bring our inequality symbol straight down. 5 plus 1 is 6. Okay, not there yet. We're solving for x. So what do we have to get rid of? Our negative 2. Since it's negative 2 times x, we will divide both sides by a negative 2. Negative 2 divided by negative 2 is a positive 1. Negative 2 divided by negative 2 is a positive 1x. And 6 divided by negative 2 is a negative 3. Now, before you bring down your inequalities, notice I divided by a negative 2. That means I have to flip over the inequality. But this is going to seem a little bit weird. I shouldn't say it's going to seem a little weird. We have 1 is greater than x, which is greater than or equal to negative 3. It's correct, but what's weird about it is we always kind of write the numbers in a compound inequality in numerical order, meaning our smallest ones should be at the left, our biggest one should be at the right, because that's what we're used to seeing. When we draw a number line, the smaller numbers are to the left. We write a compound inequality, our smaller numbers are to the left. So all you really should do, you guys, is just kind of flip around this negative 3 and this 1. But when you do that, remember, x has to be greater than or equal to negative 3. That means negative 3 is less than x, less than or equal to x. Okay? So just be careful when you run into something like this, when you have to flip the inequalities over. You still solve them the exact same way. You still have to flip over the inequality if you're dividing by a negative number. But proper math terminology says we're going to write the smallest numbers to the left. So you really need to write the negative 3 to the left. So you kind of just write it backwards. Negative 3 is less than or equal to x, which is less than 1. So you just kind of write it backwards so we can say it's in proper math form. Okay? But again, the basic concept of solving inequalities is the same, or solving compound inequalities is the same as solving the regular 1 or 2 step inequalities we've been solving.